Good evening, students. Today I am going to discussing oxidation state or oxidation number from redox reactions. Oxidation state or oxidation number, and what are the rules of oxidation number, oxidation state, and how to find out the oxidation number of central atom in given compounds. And the previous year questions also we are discussing, like JEE or NEET level questions also we are discussing. First of all, what is oxidation state or oxidation number? What is oxidation state or oxidation number? Okay, a charge present on an atom in uncombined state or combined state is called oxidation state. In uncombined or in combined, okay, oxidation state or oxidation number nothing but a charge present on an atom in combined state or uncombined state is called oxidation state or oxidation number. Okay, now oxidation state or oxidation number is real charge in ionic compounds, but is imaginary charge in covalent compounds. We see the for covalent compounds, an atom with the highest electronegative is given as negative oxidation state, and an atom with lowest electronegative is given as positive oxidation state. Okay, now what are the rules to calculate the oxidation number of the central atom in a given compound? Here some rules we are discussing. First, rules. Rule number 1. What rule number 1? The oxidation state of any element or any atom in uncombined state is 0. In uncombined state is 0. For example, sodium, potassium, magnesium, calcium. Okay, like any homogeneous molecule, any homogeneous molecule, nothing but H2, N2, O2, F2, Cl2, okay, even O3, ozone, phosphorus, B4, S8, etc. What happened? Oxidation number is 0. Either elementary form or this is elementary only, nothing but any homogeneous molecule, oxidation number is 0. That is the rule number 1. Next, what is the rule number 2? For monoatomic ions, the oxidation state equal to charge present on ion. For example, sodium ion Na plus ion. What oxidation number of sodium ion here? Plus 1. Like calcium ion Ca2 plus. What oxidation number is plus 2. Like F minus. What oxidation number here? Minus 1. Like O2 minus, oxidation number is minus 2, etc. So any monoatomic ions, what the charge present on ion, that is nothing but oxidation number or oxidation state of in that ion. Next, rule number 3. The oxidation state of any element, take any neutral molecule, the sum of the oxidation state of all atoms in a molecule is 0. Any neutral molecule, example taking for neutral molecule. For example, taking H2SO4. This is one of the neutral molecule. What is the oxidation state of this compound? The sum of the oxidation state of hydrogen, sulfur, oxygen equal to 0. For example, from here, this H2SO4. The oxidation state of hydrogen I'm taking is X. Sulfur taking Y. This oxygen taking Z. The sum of the oxidation state of X plus Y plus Z. X plus Y plus Z equal to 0. So, any neutral molecule, the sum of the oxidation state of all elements or all atoms in a molecule is 0. That is the rule number 3. Now go for the rule number 4. What is rule number 4 here? Any polyatomic ions. Before we discussing monoatomic ions, the oxidation number is nothing but charged ion. Now rule number 4 for polyatomic ions. Polyatomic ions. What happened? The oxidation state is nothing but charge present on ion. Charge present on ion. The sum of the oxidation state of all atoms in the polyatomic ions is charge present on ion. Present on ion. For example, carbonate CO3 2 minus. Okay. In this case, the oxidation of carbon taking X. Oxygen is Y. Now, sum of X plus Y equal to what is charge present on ion? Minus 2. Therefore, X plus Y equal to minus 2. This is the for polyatomic ions how to calculate the oxidation number means the sum of the oxidation state of all atoms in the polyatomic ion equal to charge present on that ion. Next rule number 5. The oxidation state of fluorine is always minus 1 in the compounds. Always minus 1 in the compounds because of the highest electronegative element in entire periodic table is the fluorine, that is minus 1. So in the compounds, fluorine exhibit always minus 1. Okay, na? And the fluorine can form only one covalent bond. Only one bond they forming. Then only the oxide of fluorine is always minus 1 in their compounds. Next, rule number 6. The oxidation state of hydrogen is plus 1 in their compounds. In their compounds. Except which compounds? Metal hydrides. Except metal hydrides. Okay, in metal hydrides, what happens? Oxidation number of hydrogen is the minus 1. Okay, generally every compound other than metal hydrides, the oxidation state of hydrogen is always plus 1. Whereas in metal hydrides, the oxidation state of hydrogen is the minus 1 because metal hydrides mean metal always exhibit plus 1. Positive oxidation number. Generally, hydrogen is a minus 1 oxidation number. That is the rule number 6. Now going to rule number 7. Followed by remaining rules also. So what is the rule number 7 here? Oxidation state of oxygen is minus 2 in their compounds. In their compounds. Except some compounds. What are those compounds? Except peroxides. Okay, superoxides and fluorides. Okay, peroxides, superoxides and fluorides. Remaining all compounds, so oxidation number of oxygen is minus 2 except these 3 type of compounds. You see the peroxides. Okay, the oxygen of peroxide, what happened? In the oxide of oxygen, peroxide is minus 1. Keep in mind. Normal compound is minus 2, whereas peroxides oxidation of oxygen is -1. For example, I'm taking here hydrogen peroxide H2O2, okay, sodium peroxide A2O2, right, like barium peroxide BaO2, etc. All these compounds what happened? The oxidation of oxygen is -1. Only have to verify. Okay. See, here hydrogen is +1, +1 into +2, +2 oxygen -2 by 2, -1. Sodium +1 into +2. This is -2 by 2, -1. Barium +2. We will discuss that points also later. Okay, then only any peroxides are present, the oxidation state of oxygen is -1. Okay. Next, go for the superoxides. In superoxide, oxidation of oxygen is -1 by 2. Okay. For example, potassium superoxide KO2, rubidium superoxide RbO2, etc. In this case, the oxidation of oxygen is -1 by 2. Keep your mind. Okay, we see here potassium superoxide. Nothing but structure of this one KO2. Now potassium is first group cation, first group element. The oxygen number is +1. You know that point also I'll give. Now potassium +1. Automatically what happened here? Overall compound neutral. Now this oxygen is -1 by, this also -1 by. -1 by 2, -1 by 2. -1. -1 is the +1, neutral. Okay, then only the oxygen state of oxygen in any superoxide is -1 by 2. Okay, and then go for the fluorides. In fluorides, the oxygen of oxygen is +1 or +2. Two are possible. For example, I'm taking here in O2F2 and OF. In O2F2, fluorine always minus for mind. Here, oxygen exhibit +1. Similarly, in fluorine also -1. Any case, any compound, fluorine is present means the oxidation of fluorine is always -1. Then you have to decide the remaining element oxidation state. Here -1 into -2. This is the +2. +2 by 2, +1. Here -1 into -2. Then oxygen is +2. Then only these two compounds oxygen exhibit +1 as well as +2 oxidation number. Okay, this is rule number 7. Then go for the rule number 8. Okay, the oxidation state of all first wave group elements, oxygen number is always +1, and second wave group elements, the oxygen number is always +2. Because first wave group elements and second wave group elements are of the metals only. Metals exhibit only positive oxidation number. Or first wave group element having only one valence electron, then they exhibit only +1. Element from 0, that is common for every element. And the second wave group element exhibit +2. This is rule number 8. And go for the rule number 9. What is rule number 9 here? The oxidation state of any element exhibit highest oxidation number is nothing but equal to group number. Any element exhibit the highest oxidation number. Any element exhibit highest oxidation number is nothing but equal to group number. Other than group number, not possible. Any element maximum or highest oxidation number is nothing but equal to group number only. For example, sulfur. Sulfur belongs to 6th group element. Sulfur exhibit maximum oxidation number is +6. They exhibit +4, +2, -2 also. But maximum oxidation number equal to any element in their compounds is group number. Okay, this is the rule number 9. Next, go for the rule number 10. What is rule number 10 here? For alloys and amalgams, the oxidation state of metal is 0. Keep in mind, the oxidation state of metal is 0. Alloys, for example, taking here brass. Okay, what is combination brass? Copper plus zinc is nothing but brass. Okay, now in alloys, the oxidation number of both metals is 0. Okay, how to see this concept again? Second year coordinate compounds are very important. And go for the amalgams. sodium alcohol both metals exhibit zero oxidation number. And finally, one more rule is there. The oxidation state of metal in metal carbonides, okay, is zero. Metal carbonides, the oxidation state of metal is zero. For example, take nickel tetracarbonate or iron pentacarbonate. Example, nickel tetracarbonate, the oxide of nickel is zero. Okay, similarly, iron pentacarbonate, the oxide of iron is zero, etc. This is also very important for the second year coordinates compound board as well as NEET and JEE levels. These are the some important rules to find out the oxidation number of the central atom in a given compound. For example, now how to calculate? Calculation of oxidation state of the following compounds. Okay. For example, take here first one, oxidation state of nitrogen in N3H. N3H means hydrozoic acid. What is the oxidation state of nitrogen in N3H? I want nitrogen oxidation number. How to find out? I don't know nitrogen. I'm taking how many nitrogens are 3. 3x, I'm taking x plus. What is the oxidation number hydrogen here? This is the non-metal hydride. As well, hydrogen is here -1 oxidation number of +1. In metal hydrides means -1. Other than metal hydrides, so exhibit +1 equal to overall molecule neutral. Then 0. 3x + 1 equal to 0. Then 3x equal to -1. Finally, x equal to -1/3. -1/3. This is the oxidation number of nitrogen in that hydrozoic acid. Next, go for second example. Oxidation state of sulfur in sulfuric acid H2SO4. How to find out here sulfur? Here hydrogen, how many are there? 2. 2 into oxygen number hydrogen +1. Because of this acid and sulfur, I don't know, I'm taking as X plus 4 into oxygen number of oxygen is -2. Overall compound is neutral, that is 0. Okay, this is normal oxygen, so that I'm taking -2 oxygen number of oxygen. Now, calculate this one. 2 plus x minus 8 equal 0. Then 2 minus 8 means 6. X minus 6 equal 0. Finally, x equal to +6. This is the oxidation state of sulfur in H2SO4. Similarly, go for the third one. Oxidation state of sulfur in H2SO3. What is sulfur oxidation number here? See, same here, same like that. 2 into +1 for hydrogen. And sulfur I'm taking as x plus 3 into -2 equal to overall compound is neutral, then one taken as a 0. Finally, 2 plus x minus 6 equal 0. Then 2 minus 6 means -4. X minus 4 equal to 0. Finally, x equal to +4. See here, in sulfuric acid, sulfur exhibit +6 oxidation number, whereas in sulfurous acid, sulfur exhibit +4 oxidation number. Yeah, like that, so many compounds you have to find out oxidation number of central atom. See some more examples, and also we'll discuss previous JEE 1 or 2 questions. This is next. Go for the question number 4. Oxidation state of sulfur in Caros has sometimes not giving name. They give the just not giving formula, just they have to give the name of the compound. What is Caros? Caros is nothing but peroxymonosulfuric acid, nothing but peroxymonosulfuric acid, monosulfuric acid. You know here, meaning is the peroxy means out of amino oxidants are there. Out of that amino peroxoxide, let's see that what is the formula of peroxy monosulfuric acid, otherwise Caros acid, nothing but H2SO5. Now, what is the oxidation state of sulfur in Caros acid? Okay, actually generally without knowing this peroxoxygen, how to calculate this, how to get oxidation of sulfur 8 is coming. So there will be, for example, option A plus 6, option B is plus 8, option C is the plus 10, and option D is the plus 4 like this. What is oxidation state of sulfur in the Carros acid? How to find out? Okay, this is the structure of Carros acid sulfur, like S double bond O, then bond OH, and the remaining two oxygens with like peroxy bond. These two oxygens, peroxoxygens, then only they exhibit -1, -1. Remaining three oxygens exhibit -2, that is +1. Have to calculate among these 5 oxygens who are the peroxoxygen, remaining 3 only normal oxygen. Then only have to calculate 2 into +1 plus x plus 3 into -2 is the normal oxygens, and 2 into -1 is the peroxy oxygens. Then only have to write like this, and here 2 into +1 plus 2, 2 into minus cancel each other, and finally x minus 6 equal 0, then x equal to plus 6. Then answer is the plus 6, not plus 8. Directly can apply, it is the plus 8, but plus 8 is wrong because sulfur belongs to 6th group element. Any element exhibit highest oxygen number equal to group number only. Then the highest oxygen number of sulfur is a plus 6 only, but not plus 8. Directly can go for the 5 oxygens normal can take to get answer plus 8. That is wrong. Cannot keep in mind to do properly. Okay, then go for some more examples. Okay, I am taking another example, like example number 5. In case oxidation state of sulfur in Marshall's acid. Marshall's acid. What is the formula of Marshall's acid? The chemical name I will have to give that. That is peroxy disulfuric acid. Peroxy monosulfuric acid, nothing but Carros acid. Whereas peroxy disulfuric acid is nothing but Marshall acid. What is the formula of peroxy disulfuric acid or Marshall acid? That is H2SO8. H2SO8 is nothing but peroxy disulfuric acid or Marshall acid. Okay, in this case, peroxy means, keep in mind, only 2 oxygens. 2 oxygens peroxy. Out of 8 oxygens, 2 are the peroxy. Remaining 6 normal. Before case, out of 5 oxygens, 2 only peroxy. Remaining 3 normal oxygens. Now, other case is the structure of this one. Here, S double bond O, bond O, S double bond O, bond H. This is also O, bond H. This is the structure of Marshall's acid or peroxy disulfuric acid. Now, you can see here these 2 oxygens are peroxy. These 2 oxygens exhibit -1 oxidation number. Remaining all -2 only. Total how many oxygens are -2 oxygen number here? 6 oxygens. Only 2 are the peroxy. And it is +1, you also +1. How to count and do it. Again, otherwise, direct have to here. Ideal sulfur are there 2 into +1 plus how many sulfurs here? 2 sulfur taken as a 2x plus out of 8 oxygens, 6 are the normal and remaining 2 are the peroxy oxygens. Then oxygen number peroxy is -1. Overall is no 0. Because compound is a neutral compound, and the overall compound charge is 0. Now we have to calculate. Here +2 -2 cancel each other. Then 2x -12 equal to 0. Then what happened here? 2x equal to +12. Finally, x equal to 12/2 plus 6. See, this is the oxidation number of sulfur in Marshall acid or peroxy disulfuric acid. Similarly, go for the oxidation state of sulfur in oleum. What is the formula of oleum? H2SO7. H2SO7 is the formula of oleum. Okay, same method, but here there is no peroxy. This is the just disulfuric acid. Oleum is nothing but disulfuric acid, not peroxy. Keep in mind that names also have to keep in mind. Along with the common name as well as chemical name also. Disulfuric acid, nothing but oleum. In this case, there is no any peroxy oxygens. But whereas Marshall acid or peroxy disulfuric, then only there 2 oxygens are peroxy oxygens. Whereas oleum, there is no peroxy. All 7 oxygens are normal only. Directly have to do. In this case, what are we have 2 ideals are there? 2 into +1 plus 2 sulfur with 2x plus 7 oxygens, 7 into -2 equal to 0. then 2 plus 2x minus 14 equal to 0. Then what happened here? 2 minus 14 means 2x equal to 12 and then x equal to plus 6 only. See here? In ferrous acid, sulfur exhibit plus 6, master acid also sulfur exhibit plus 6, and only also the oxygen shade of sulfur is the plus 6 only. Don't get confusion. These two compounds having peroxyoxygen, two peroxyoxygens are there, whereas oleum does not have any peroxyoxygen. All of them normal oxygens only have to calculate directly. Okay, this is the way to calculate the oxidation number of any given compound central atom ion. Okay, like go for the some more example and I'll do 2-3 questions also previous JEE. Now go for second one more example. What is the oxidation state of carbon in carbon suboxide? Carbon suboxide. What is formula of carbon suboxide here? Formula of carbon suboxide nothing but C3O2. C3O2 nothing carbon suboxide. What is the oxidation number of carbon here? There are 3 oxygens. I don't know, for example, 2 oxygens and 3 carbons. I'm taking 3x plus 2 into oxygen of oxygen is minus 2 because it's normal oxygens only. Now 3x plus 2 into minus 2 minus 4, then 3x equal to plus 4, then x equal to plus 4 by 3. The oxygen number of carbon in carbon suboxide is the plus 4 by 3. The overall average oxygen number of each carbon. Sometimes they ask me what is the oxygen number of second carbon. Like that will ask them. Then what is the structure of this carbon suboxide? C double bond C double bond C double bond O double bond. This is the structure of carbon suboxide. With respect to oxygen is minus 2, carbon is plus 2. This oxygen minus 2, carbon plus 2. What about the oxidation state of carbon in central carbon? The asking. This is the GO. Like that also asking questions. Very important is also. Okay, very important. What I am discussing, all compounds are most important. Previously asked questions also. The oxidation of carbon in carbon suboxide, central carbon, otherwise second carbon, is 0. Average is the plus 4 by 3. Yeah, first carbon plus 2, third carbon plus 2, but middle carbon oxygen number is 0. Okay, clear students? And also if we see one more example, what is the oxygen number of chlorine? CaCl2, like nothing but bleaching powder. What is the oxidation state of chlorine in CaCl2? Overall, you can take means what happened here? Calcium is plus 2, oxygen is minus 2. Okay, and chlorine 2x of taking 0. Plus 2 minus cancel. Then 2x equal 0, x equal to 0. Oxidation of chlorine 0. Overall, you can take average oxygen number of chlorine 0. But whereas separate you can go for one chlorine getting minus 1, other chlorine getting plus 1 also. We see the structure of this one, CaOCl and Cl. Here calcium is plus 2. Okay, now direct attachment, chlorine is minus 1, oxygen minus 2, this is the plus 1. See here, plus 2 minus 2 cancel, plus 1 minus 1, plus 1 minus cancel. Then only one chlorine exhibit plus 1, other chlorine exhibit minus 3. Each chlorine directly attached to the calcium is oxygen number minus 1, with oxygen is plus 1. This is the oxidation state of each and every chlorine in the CaOCl2. Okay, and one more thing, last JEE session 1, they asked some questions. I'll give one of the questions, that is JEE questions. We see like session 1. Which of the following does not exhibit variable oxidation state? Which of the following element does not exhibit variable oxidation states? Variable oxidation state or oxidation number. They given options: option A F2, option B Cl2, option C Br2, option D I2. Easy, no? Does not exhibit variable oxidation state. Only fluorine. Fluorine exhibit always minus 1. Answer that. Yeah. Chlorine exhibit minus 1. See here only. Plus 1, plus 3, plus 5, even plus 7. Maximum plus 7 exhibit. These group elements exhibit except the fluorine, M exhibit maximum group number also up to +7. But fluorine exhibit only -1. This is not variable. Variable means what happened? Any element exhibit minimum 2 or more than 2 oxygen state, that is called variable oxygen states. And also one more question they asked. Among the following compound exhibit +4 oxygen states. That is integer type question. +4 oxygen exhibit compounds +4. They given barium sulfate BaSO4. Okay. Next to SOCl2. Okay. Sulfur they asked me. Next to SF4, H2, SO3. Next to H2S2, O7, SO3. How many among these following compounds? How many compounds exhibit +4 oxidation number? Tell me. Here among these compounds, how many exhibit +4 oxidation number? If you take here barium, sulfur exhibit whatever here X. Barium is nothing but +2, X +4 into -2. Okay, what is getting here? 2 minus 8 minus 6, x equal to +6, not possible, wrong. In SOCl2 what happened here? SOCl2 oxygen exhibit -2, fluorine exhibit -1 into -2, -2, -2, -2, -4, sulfur exhibit +4, correct. In SF4 fluorine -1, -1 to 4, -4, sulfur is +4. And HTSO3 already we discussed previously. So this is +1 into +2, this is -2 into -6 +2, -4. Nothing but sulfur is +4. Next here already previous I discussed here +6, because 7 into -2 -14 and +2 -12, and the +12 by 2 +6. Here 3 into -2 -6, sulfur is +6. How many here? Answer is the 3. How many compounds exhibit here? +4 oxygen number means 3 compounds are exhibited. This is the previous session 1, 27th exam question. Okay. This is some important concept regarding oxygen state, oxidation number. How to calculate oxygen number of central atom given compound. Very very important. Either JEE or NEET level also. Okay. Thank you.